Okay, so your shape is, get that up there, x squared minus y squared.
Yep.
And you thought people might think this was the same as x minus y squared.
Yep.
Okay. All right, so what do you think x squared minus y squared is going to look like?
So might have some negative parts. It's probably gonna have some negative parts to it.
Okay.
And I think it's probably gonna have a line that is this x squared minus y squared equals 0.
Oh, you think that's going to be a line?
It might be sort of like a line.
Okay. Interesting. Let's take a look and see. There. Oop. Looks like I have an extra parentheses in it. There it is.
Well, it doesn't look like it has any lines. It
Looks
just
sort of
looks
like a saddle.
Sort of has a curve to it.
Yeah. Interesting. I think there's a function called contour plot. You're gonna get an interesting surprise. I bet extrusion, which is a 3D printing command, is not part of contour plot. So the curves drawn in black in this shape are the same equal values. Do you see any lines?
Well, there's just like these two lines crossing the screen.
Can you tell me what those lines are? Those are where x squared minus y squared equals 0. So what are those two lines?
So x squared minus y squared equals 0. So that's, I guess, x squared, or it's the absolute value of x equals the absolute value of y.
Okay.
And that's what this would look like. You'd have two lines. It's x, y equals x, and y equals minus x.
Okay. Can you see from the equation x squared minus y squared equals 0 that you're going to get those two lines?
You can,
By factoring.
well, you can use difference of squares.
Okay, what does that factor into?
That says that x plus y times x minus y is going to have to equal 0.
Okay.
So either x plus y is 0, which means that x equals minus y, or x minus y is 0, which means that x equals y.
Cool. So your intuition that there were lines here is exactly right, but the interesting thing is, when we go to plot 3D, where are those lines? Where are those lines where this thing is equal to 0? Can you see them? Because your initial reaction was there weren't any lines here and it was just a saddle. By the way, the saddle is the mathematical name for this. Can you see those lines where it's equal to 0?
Oops. Not really from above. I can't really see them.
Can you?
No.
There's no sort of straight.
So when we go back to contour plot,
There's two lines of where it's 0.
okay. So where are those lines going? How are those lines
They
moving?
look like they go from corner to corner.
Okay, corner to corner.
So it seems like they're going across here.
Yeah. So can you see the z value in this corner? What is it?
0.
And what is it over here?
I
think it's also 0.
Zero too.
Okay. So there's a straight line. It's very hard to see, but it's a straight line of there, and there's a straight line running across there. It's hard to see.
Yeah.
That's why contour plot is actually really useful. So you thought this would you thought some people might think this was equal to x minus y squared. So what do you think x minus y squared is going to look like?
It's minus y squared. This is not gonna have any negatives in it.
Okay.
So it might look sort of the same thing, but without the negative values.
Okay. Do you have a guess for what this is going to look like? X
I
minus
think
y
it'll look like pretty similar to our x plus y squared shape.
Okay,
Maybe, well,
let's see.
it looks
So that we can see the
like flatter. But
zero
that might
line.
just be a trick of Mathematica.
See that line there.
You can see that 0 line, yeah. Yeah, that is a trick of Mathematica. So this, our other shape, and I told you it wasn't gonna look very good on screen, does it? Can you look through the viewfinder?
Yeah, you can kind of see it.
So it's actually pretty much the same shape. X plus y squared that we looked at before, and x minus y squared are very similar looking shapes. One's just rotated because in one case the 0 is where x equals minus y, and the zeros here are where x equals y.
Interesting.
Yeah. So you can actually see the x and y values there.
Yep.
Equal. Okay, so good. Good job, guys. That was actually really fun. This is a nice example because of that saddle for x minus y squared. That's a shape you probably haven't seen before
Yep.
mathematically, but you see it. See it here. All right. Good job, guys. High five.